love this unicorn here. This is one of my Friday hugs. Actually, so I don't think, okay, on Friday, typically I, have my Friday hug on Twitter, right? Like, I'm excited for the weekend, and I try to give everyone a hug on Friday for the weekend. And I would like to give all of you guys a hug, but I just don't think it's possible, like time-wise, to hug every single person individually. So what I would like to do is have kind of a group hug from all of you that I can post on Twitter and say Happy Friday to everybody. So I'm going to have my lovely assistant, my fiance Ebby, come take a photo of all of us saying hugging for Friday. So come out. Okay, I'm gonna come down here. I want everybody to go like, all right, on the count of 3, we're all gonna say Happy Friday, and I want you to go like this, and then she's gonna take a photo. All right, ready?
Yeah, we're leaving, guys. No,
all right.
Wait.
Okay. Are we ready?
I think you won't be in the picture if you don't come out.
Are we? Huh?
We have to do this.
We're all gonna go like this and say, or we can hug each other. It's really like, Friday hug is what you make of it. So, all right, I'm just gonna say on the count of 3, we'll say Happy Friday, and then she'll take the photo. All right, ready? 1, 2, 3. Happy Friday! All right, thank you. All right, I'm very honored to be the first one to welcome you to Railsberry. Or as I like to call it, Railsberry. First off, so how many of you have a Mac? Sweet. And how many of you have a Wii? Awesome. So go get this program called Darwin Remote, and you can use your Wiimote with your laptop like I am doing. It's very fun. So my name is Aaron Patterson, and you can tweet at me at tenderlove or email me. So if you have questions about this presentation after I'm done and you don't remember it, just tweet it at me or email at me, and I will get back to you. So please do that. I work for a company called AT&T Interactive, and I have to say thank you to them because I am paid to work on open source full time. So my full-time job is to basically do nothing all day. except that somehow my job is to do nothing all day, and yet I feel like I'm insanely busy, so I'm not quite sure how that works. But I'm a senior software engineer. I'm on Ruby core team and the Rails core team. I get insanely nervous at conferences when I'm giving talks, and I said to Jose Valim, I'm like, every time I give a talk, I'm so nervous. And he said, well, just think about what would Freddie Mercury do? Think about that when you're on stage. So I have this slide here that's like, okay, what would Freddie Mercury do? Calm down, you'll be okay. So, I want to talk about, we've seen a lot of awesome technology at this conference. Like things like Elixir, Celluloid, Bundler, Rails, Sinatra, Sprout Core, and Travis CI. Now, what do these projects all have in common? Awesome logos. Really, really awesome logos. And I want to say to you, like, if you're on a project that has like a really awesome logo, you need to stop it. Seriously, stop it. And the reason you need to do that is because, like, take a look at the logos for my projects. This is for one of my projects. This is like Nokogiri. Like, you can see I tried to make it fancy with the G, like swoop around and stuff. I got some hearts up there. Like, it's just not fair. It's really not fair to me. I am not a design person. I can't design my way out of a paper sack, so just don't do that, please. So anyway, what does this have to do with the rest of my presentation? Nothing. I just have to implore you people, please stop being so awesome at, your logos and stuff. So my talk is titled Code Charcuterie. I'm an amateur charcuterier, and you can tell that I'm an amateur because I can't spell it. I really have no idea what the spelling is. And a charcuterier is a person that cures meat. So charcuterie is curing meat, and so I've started to learn this process. And this is some of the stuff I've made. This is my first cured meat. This is a pepperoni. Here it is cut up, and I want to show you I want to talk a little bit about curing meat and show you my setup. And so this is my setup. I made a drawing. So I've got this box right here. This box is a wine cooler, and those things there, that's the meat hanging down. And over on the left there, that's a humidifier. And I've got a little box right there that controls the humidity inside the box. So when you're curing meats, in order to cure meat, what you have to do is you have to control the salt content, the sugar content, and the water content of your meat, right? And the idea is that, you also have to put bacteria into it. And the thing is that you're actually trying to rot your meat, but you're trying to do it in a controlled way. So what you want to do is you want to put these bacteria into it that are good bacteria that are okay for you to eat and won't make your meat smell bad or all this stuff. And you want that bacteria to crowd out any bad bacteria that might try to get into your meat. So that's the idea. We have to control these variables in order to make it a good environment for our bacteria, but a bad environment for foreign bacteria. And the things that we have to control outside the meat are the temperature of the box, which is why I'm using this wine cooler, as I can control the temperature of the box. We have to control the humidity, which is why I have the humidifier there. And down here I have a little fan. We also have to control airflow across all the meat. So I want to show you a little bit larger part of the setup is so that's my box right there. That's the meat box, obviously. And the problem is I have to power this fan, right? And the fan is a USB fan. So that purple thing is my laptop. So I've got a power cord running out of it into my laptop where I work all day. But I mean the problem is this is obviously bad because it's tight coupling. So if I go anywhere with my laptop, my sausage box is not doing its job. So I was thinking about talking about tight coupling, but yeah, I'm not going to do that. I actually want to talk a little bit about Rails internals. But well, first I want to tell you. So I finished curing this meat, right? And you're supposed to. So one of the ways that you test to see if the meat is okay is you test its pH. What happens is this bacteria eats away at the sugar in your meat and creates vinegar basically, and it makes your meat tangier and more acidic. So your pH should drop. So one way that you can tell that the meat is safe to eat is you measure the pH along the way, and you can graph it. And I have books that say you start out at 6.5, and by the time you're done, your pH should be down around 5.6, I think, if I remember correctly. So I bought this really awesome pH meter, and I was measuring it along the way, and when I got done with the meat, my pH was supposed to be at 5.6, but it was actually 7.2. And I was ooh, man, but it looks really good. So I think I'm gonna try it. So I tried it, and it was delicious. It was really good, right? So I cut up some of it, and I gave some of it to my coworker, my boss, and he ate a couple pieces, and I didn't tell him about the whole pH thing until after he had eaten some of the meat. And so he's "Are you trying to kill me? This is not safe. How are you doing this?" I'm "Oh, I'm sorry. I probably should have told you that first." So the moral of the story is that I need to set expectations. So that's what I want to do with you guys today, is set expectations about this talk. Oh, and I don't have a clock, I guess. Can someone like warn me when I'm getting too close to my time, please? So we're going to talk about instrumentation, concurrency, and active record attributes. So what I want to do is I want to walk through this. I want to walk through this presentation, and we're going to look at these different things inside of Rails and how they work and like how I've changed them. But I also want to like talk about my thought process as I'm looking at the code. So we're going to look at actual code from Rails source, and like I kind of want to have like basically a dialogue of what's going on in my mind when we look at this stuff. So along those lines, I have basically I have a chart of doubts. So like down here is like, all right, so we've got few doubts. I'm okay with the code if our chart is down here, and like if it's really bad, then it's going to move up, and we're going to say like, oh man, I have many doubts about this code. So I'm going to like pop this chart up every once in a while in the slides and say like, basically is our WTF meter, right? So this is my personal WTF meter, and I want to talk about like why I think that way. So the first thing we'll look at is instrumentation. So this is like, instrumentation is basically, in Rails, it's basically a notification system. So we have like one area where we send events, right? And then we receive events, and we can do stuff with the events. So this is how we actually send an event. We say like, well, okay, we're going to send the event named register, and inside the block, that is the thing that we're measuring. That's what we want to tell people about, right? So then when we subscribe to it, we say like, okay, well, this is how we subscribe to it. I want to know about all render events. So every time a render event is fired, we have this block, and we get this event, this block fired, and we know about that particular event, right? So this is the actual source code inside of Rails of what that instrument method looks like. And what happens is, like, first we say, okay, well, instrument render. And we say, well, what time is it now? Like, it's now. It's now. So we yield to that block and let you do your work, or whatever in the Rails framework does its work. And then this notification is published to all the people who are listening, right? And it's published with that start time. The important things we need to note here is it's published with that start time, and then we say like time.now to say like, okay, well, now we have a delta, right? We know it started now and it ended now, so we can figure out like how long it took, how long that yielded block took. But if we think about this a little bit, we have a problem here. One of the problems is that like, we're not seeing if anybody's actually listening, and even though like maybe nobody's listening, we're still trying to figure out what time it is. So we're still trying to do these basically delta calculations, even though we don't know, like maybe nobody cares, right? So that's one kind of annoying thing. And the other annoying thing is that, well, we get this publish event happens after the event finished, right? So I'm getting a little like, this code is kind of concerning me a bit. I'm like, well, why are we calculating these times when nobody's listening? Well, how do I know, like, we only get one event here, and that's when the event ended? I mean, what happens inside this? Like, we know that delta time is our time plus our children's time, like whoever, maybe there was other events that happened inside our block, but the problem is we don't know, like, well, we received this SQL executed event and we received this view rendered event, but did the SQL executed event happen inside of the view rendering, or did it happen before the view rendering? And it's really tough to tell that. Like, we actually have to go in and look at all these timestamps and say, well, oh, was this one before this one and this one before this one, and do all these calculations to kind of try and back into that event system. So at this point, my doubts are getting very increased because I'm like, nobody should have to do this work. Why do I have to, why do I have to figure this stuff out? So we've got this missing information here, and the missing information is, well, when did the event start? If nobody's listening, why do we send this time information? What we would really like to see is something along the lines of this, where we say like, well, okay, we want to know that we started rendering some page, and then we started executing some SQL, and then we finished that. Maybe we executed another SQL, and then we finished that, and then finally we finished the rendering. That would be our ideal situation. So if we had all this information, we could say like, oh, well, obviously these two SQL statements are, our view is actually causing these two SQL statements to be executed. It would be nice to know that information. We could actually build a tree out of that and say like, oh, okay, we're rendering this template and it's actually executing two SQL statements. This would be nice information for us to know. So I wanted to change Rails to support this, and well, I didn't know quite how to do it, so what I did is I just wrote the code that I wanted it to be. Like I said, well, I want a listener, and I want this listener to get a start event and a finished event. And I just called into the notification center and said, okay, here's my thing. And of course, Rails blew up, like completely blew up, saying, oh, well, you don't respond to call. This object is just completely wrong, which is expected. I didn't change anything in Rails, right? So I said, okay, well, I'll change Rails. So I changed the instrument method. I said, okay, well, now I want to send a start event and a finished event. And that was great. Like, my little test case there worked, but I completely ruined the rest of Rails. Like, basically, pretty much every test was failing. And the reason every test was failing is because, like, we use this instrumentation system. We use this for logging. Like, it's used all throughout the Rails system. So, like, changing this, fundamentally the way this worked, just blew everything up. So I said, okay, well, how can I make this work? We had, before we were giving this method a block, and now we're trying to give it an object, and we need to make this block quack in the same way that the object quacked. So how can we do that? What I did is I introduced this timed class where I said, okay, well, what we're going to do is we're just going to introduce a class that has a start event and a finished event, and we'll just call into the block on the finished event in order to keep backwards compatibility. So we can say, okay, let's keep track of the block that the person passed in, then keep track of the start time in a stack, and when we get the finished event, we'll pop off the stack and pass all those original attributes back into the block. Then inside our subscribe method, I say, okay, well, does the listener respond to call? If the listener responds to call, it's probably a block and it's expecting this older API. And if that's the case, then I'll basically instantiate this new timed class to wrap up the block. And if it doesn't respond to call, then we'll just use this object. So in this way, we're able to keep backwards compatibility. All the tests passed, everything was happy. And a side benefit of this is that now we're no longer calculating start and end times if nobody is listening. So if somebody is listening, we'll actually do those calculations, but if nobody's listening, then we've saved ourselves some time. So our reward for this is that, well, now we can write this class here that receives these start and finished events and actually print it out and see what's going on. So this is the entire class, and this actually works on Rails master today. This code in this slide does. And we say down here at the bottom, okay, I want to listen to every single event in the system, and I want to print out basically a tree of it. And the output looks like this. So we can say, we're processing a controller, it's processing a view, and we can see everything that's happening inside there. What else is cool about this is that we can construct a tree from it and actually output a graph. I know you can't read this, but we're going to zoom in a little bit and take a look. So this is my application performing one request, and it does a SQL query and renders some stuff. And we can see like, okay, well, down here we've rendered a view. Up there we've rendered action view, and it took 5.65 milliseconds, so that's how much time I took, plus my children. But we can also see how much time each of the children took, and actually calculate, oh, okay, well, this is how much time I spent. So we can see this information. And if we go back up here and look at the controller, we can see, my messages controller, I was performing a get on index, and I did this SQL query, and it took so long, and then finally we render some views and stuff. So this is our reward. The next thing I want to talk about is concurrency. We've heard a lot about concurrency at this conference, and I want to talk about concurrency kind of with a Rails spin, if it were. Actually Rails and MRI specifically is what I want to talk about. First thing I want to talk about is Amdahl's law. Anybody heard of Amdahl's law? Yes, a few of you. Amdahl's law is awesome. This is Amdahl's law, and what Amdahl's law is a formula to figure out, well, if I have a particular program, how fast can I make this program by parallelizing it? Okay, what is the potential speed up that we can get out of this program? And what P is P represents the percentage of our code that we can run in parallel. And N represents the number of CPUs that we're going to be running on. So using this formula, we can figure out, okay, how fast can I speed up my program? So I want to look at this, let's take a look at this in an actually using it. So let's say we have a laptop, and our laptop has one core, and every time we call laptop.execute, it's going to execute this job on a core in its machine, right? So we say okay, 10 times, I want you to sleep, we're going to sleep, 1 second. So we know we have one core, and 90% of this is parallelizable. So we can run sleep on one, our main thread, and then run the 9 others in parallel. So 90% of it is parallel. So we plug in, okay, 0.9, we divide by 1, and this comes out as 1. So we can make it 1 times faster, obviously. Right, so it's going to take 10 seconds. We run it, takes 10 seconds. Yay, amazing, our laptop with one core is awesome. But I went down to the Dell store, because Dell sells these machines that have infinite cores. Picked up one of these new infinite core machines, and the awesome thing about infinite core machines is, well, besides having infinite numbers of cores, Amdahl's law becomes a little bit easier, because that fraction where we calculated, say, we divided by the number of cores we have, as it goes to infinity, that fraction actually drops out, and we can just say, okay, well, it's 1 over 1 minus p, which is 1 over 1 minus 0.9. We say, oh, that's 10. Okay, so we can speed up, on infinite cores, we can actually speed up this program by a factor of 10. And we run this program, and sweet, it's 1 second. Just what we expected. That's great. So I want to look at modeling our machine, like how we might actually do this. How, nobody has a laptop class in their Rails app unless you're a Dell or something and you're selling your computers. Maybe you have a laptop model. I don't. But the way we might model this is let's say we have a queue. We would normally use a queue, and we would push all of these workers onto the queue and then have, our 10 cores running all of them. So down at the bottom, we've got our 10 cores saying, okay, we're going to pop off some work from the queue and do this. And we run it. And the problem with this program is calculating our P. How do we know, this is very similar to the previous program we looked at. We would think, oh, it's 0.9. It seems exactly the same. But the problem is we actually have this queue in here, and pulling things off of the queue is something we can't do in parallel. Each of the threads has to lock whenever we pop something off of that queue. So let's say we have a slow queue here. This queue takes 0.1 seconds to pop something off of the queue. When we run this, we'll actually see that it's slowed down. It's actually taking 2.1 seconds now. And the problem is that we didn't take into account how long it takes to pop off that queue. So the point I want to make with this is that we have hidden places where we're doing things in serial. We have hidden sequential code, and a queue is one of those hidden sequential places. And I want to look at some of the other things that impact our P in Rails. For example, I want to look at thread starvation. Thread starvation is when we have scarce resources. And my favorite example of having a scarce resource is my cat. So the problem with having only one cat is that there's me and there's Ebby, and I am constantly holding on to the cat and I am hoarding this cat. I don't give her any opportunity to play with the cat, so she is starving to play with this cat. And that's the problem that we have with thread starvation, is that we have some particular scarce resource, and not all threads can get access to that resource. Where we see this most commonly is with the connection pool in Active Record. So the problem is that database connections aren't thread safe. Okay? They're just not thread safe, and we don't expect them to be thread safe. So what we do is we map these connections as one-to-one per thread. We say, okay, well, you have a new thread. We're going to give you a new connection for that particular thread. You do all of your work against that connection. So my number of doubts is kind of increasing here because the connection pool in Rails is the thing that actually does this enforcing. It actually enforces the fact that one thread should be mapped to one connection. And I don't really think that that's a responsibility of the connection pool. I'm not sure why we have the concept of threads coupled with the connection pool. That kind of bothers me. But we'll continue. And what it means is if we grab the connection pool in the main thread and we pull the connection off of it, we'll see that the connection has the same object ID. So that's not terribly surprising. But let's say we do, create 5 new threads and we have a connection pool of 5. Every one of these connections in this 5 times loop is going to be a different object. And the problem is, none of these threads up here are actually checking in their connection when they're done with it. And what's going to happen is when we have this 6th thread come along here and try to get the connection, the pool is going to block and say, all right, you got to wait. Wait until one of these other connections gives up their, or one of these other threads gives up their connection, and now you can use it. So this is a case where one of our threads is starving based on the connection pool. Another thing I want to look at in Rails is queuing. So, well, I guess this isn't specific to Rails, but the idea here is that, well, we don't want to starve those threads that are looking for the connection pool. And we know that those particular threads are going to be doing a bunch of I/O work with the connection. So what we want to do is we want to split up our work into 2 different queues so that we can get better parallelization out of our system. So we know we have some work that takes CPU, and we know we have some work that takes I/O. So we have all of these threads that actually use the Active Record connection pool sitting on the I/O queue, watching that and doing work with the database connection. Then any sort of CPU-intensive things we put onto the CPU queue. Now the CPU queue might actually put things onto the I/O queue so that it can get some database work, and the I/O queue might put things back on the CPU queue. But we're actually getting better parallelization out of our system because our I/O queue none of the threads in our I/O queue are starving for database connections. So maybe we have a consumer that looks like this. Well, we need to save this record, so we take the saver and we put that onto the I/O queue, and we have, create post record, which only does CPU work. It's just instantiating posts and putting it onto the queue for the I/O queue to pop off. 10 minutes. Shit. So this is a diagram of what's going on, right? We're getting parallelization. Down here is our threads. We can read off I/O, go to the database, go back to the CPU. It's awesome. So I guess I have to go a little faster. I'm sorry. So let's say we have a CPU-intensive activity like the Fibonacci sequence. We run it 2 times. I used to work in online advertising, and in online advertising, that's what we do is compute the Fibonacci sequence over and over again. Pro tip. So if we run this code, it takes 3.3 seconds, right? And we're like, okay, we got to speed this up. We're going to put each of these Fibonacci calculations into its own thread. Twice as fast. And we do that, and we're like, okay, sweet. Put it in 2 different threads. We run it, and what? It's slower. It's slower than the original. Why is it slower than the original? The reason it's slower than the original is because of MRI's GIL. When you run a process under MRI, all of your threads are automatically starved for CPU. because of MRI's GIL, whenever you're doing any sort of calculations inside of the Ruby VM, it uses that single core. So the reason this is slower is because we actually have two different threads contending for the CPU. So we see this time here is the time it took to figure out our Fibonacci sequence and the time it took to schedule those threads. So not awesome. But we do have, like, let's say we have a slow mail server here. Slow mail server starts up, takes 0.5 seconds. We have a TCP client that reads from that mail server, and we need to do it 5 times. So we run this program, and of course it takes 2.5 seconds, right? Okay, that makes sense. But we want to get this a little bit faster, so we say, okay, let's put these sockets into 5 different threads and run it. And well, we learned from the previous parallelization, like MRI couldn't do that. You know, we couldn't get any parallelization out of our Fibonacci sequence, right? So we expect, well, this is probably going to take longer, right? The previous one took longer, so why not this one? But we run this example, and it actually takes 0.5 seconds. It's actually faster. So we have to say, well, why is that? And the reason is because in MRI, whenever you're scheduling work to be done on some sort of socket or file handle or any sort of I/O object, MRI says, okay, well, it basically does a select across all of these I/O handles and says, well, are you actually ready to read anything? And if you're not ready to read anything, it doesn't schedule that thread. So it schedules anything for CPU-intensive activities, but all of these I/O activities we can actually spread out. So let's say we're sending email, and I've seen this a lot, like I've written this myself. I deliver some email from a user controller, and my doubts increase here because, you know, my mail server is all of a sudden slow, and my users are waiting for me to send mail to them. Why am I doing that? Why did I do that? I don't know. So I say, okay, well, let's create this object and do this later. So we'll just create an object, put it into a queue, and do it later. And I run this little mail sending app I run on Heroku, and I'm insanely cheap, so I just have this sitting in the background. I've booted this up on initialization, and also I don't care if my users lose email. So we just pop it off in a thread here, but the important thing is that we're outside of the main run loop, so we're getting more parallelization out of this. So what I want to end with here is I want to say, well, you are encouraged to use threads. Please use threads, but make sure that you know how they work in the particular VM you're using. I/O can be parallelized, but CPU cannot. And I have to put a little star up here because this is specific to MRI. This isn't true in other Ruby VMs like JRuby or Rubinius. So you need to know the VM that you're targeting. Oh my God, how much time do I have? Like 2 seconds? 5 minutes? Okay. All right, attribute accessors, this part. Okay, I started writing these slides and I got insanely angry. So I'm afraid that my anger is going to come out here. But we'll go through it quickly. So we have a post. Everybody's seen this, right? Use this in active record. And I want to know, well, how does title, like, how do these methods come into action? Like, how does this come to be that we have a title method? It's awesome. It's very helpful. But how does it happen? Well, first thing we need to know about it is that these methods are lazily defined. So if we ask for the instance method name, we're going to get an error. But then if we do new and we ask for it again, it'll actually exist. So if we run this, we'll see, oh no, there was no method. And then the second time we ask for it, it's like, oh yeah, we got that method. Nice. So when does this happen? If we go look inside of active record, we find, okay, well, it happens inside of method missing. So if you try to call a method on that object, it says, hey, are the methods defined? If not, let's go define them, and then super. And it also happens in respond to. So we say, okay, well, are the methods defined? If not, super, or I'll define them, then super. But you'll notice in my last slide, I never called respond to, and I never called a method. I just asked to see if the method exists, and yet somehow it does. See, we just called new here. So how did this happen? And I want to know that, so I said, well, okay, well, let's see, who called respond to? Let's go take a look at that. Did a little puts debugging there. That's how I roll. And we see, well, the first one is somebody called name equals. Respond to with name equals. Does name equals exist? That seems legitimate, right? You might have implemented name equals, and we need to use your method. But this second one here, what? Run something something, initialize. I have no idea. Why? I never wrote that. Why would I ever respond to that method? It's asking, why do you respond to this? I would never respond to this. And so I'm like, why is this happening? And it turns out, well, this is because of hooks, callbacks in active record. We have these things we can say after initialize. And we say, okay, well, whenever your object is initialized, it calls this method. And I'm like, okay, all right. Well, why would I ever write this? Why would I ever use this? Because I can just implement initialize, call super, and then call my method. Why do I need to know about this callback system at all? It boggles my mind. So my number of doubts are increasing. And if you can't, I don't know if you've gathered this by now, but this is how my yak shaves start. I go look at this and I'm like, what the hell is going on? And I go dive into that code, but we're getting sidetracked. We wanted to look at how are these methods defined. Well, okay, what if we called it 10 times? What if we did this 10 times? We look at the respond to. It's called 10 times. 10 times. Why is it called 10 times? We had to set that after initialize hook in class definition, so we know in advance. We know in advance. It's not going to change. Can't change between every time we call new on post. Why is it asking this? So my doubts are increasing again. But we're getting sidetracked. We're totally sidetracked here. We want to look at define attribute methods. This is the method that we want to look at. Like, okay, this is an active record. This is where the magic happens. But I look at this code and I say, well, what? We've got this superclass.define attribute methods. Isn't super my superclass? Why do we have this superclass method? I don't understand. And then on the next line, we actually call super. Why? Why? I don't know. Actually, I do actually know. But the thing is, basically, 0 of you know. Maybe John is in the audience. I'm sure he knows. But then the other problem is okay, well, super here. We call super, but this method definition is different than our superclass. Why does that make me mad? So we have class A. Class A has high stuff, and we have class B, and we say class B is an A. It is a A, right? But high doesn't respond to with the same method arguments that A does. Why is this bad? So let's say you have this method called calls high, and it calls high with an argument, and we pass in A, and everything works. It's great. But we pass in B, and it explodes. Oh, God. Okay, very quickly. So this explodes, it sucks. And the reason is because, the reason I don't like this is because if B is an A, we should be able to use B as a substitute for A. This is what's called the Liskov substitution principle. But we can't do that here, it breaks, because the method definitions are different. So my doubts are way up here now. I'm dying looking at this code, it's killing me. So we'll go look at define attribute methods. And this is inside of active model, and we go, okay, well, it calls define attribute methods. Let's go take a look at that in active model. And this is all it is. It says attribute names.each, and then it loops over this. Because you might want to use something besides each to loop over attribute names. Why is this abstracted for me? I don't understand. Thanks, active model. I appreciate you for abstracting each from me. It's really handy. So we saw that calls define attribute method. Let's go look at that. Define attribute method. I'll read this. Is it already implemented? Okay, that seems legit. We want to know, is it implemented? If not, but then it says okay, we got this method definition name. Do we respond to that? If we do, we send it. And then finally, we might call this define optimized call. But I'm like, what? Define optimized call? Why aren't they all optimized? Why is this? If you have optimized or do it fast or whatever in your method name, you're doing it wrong. They should all be fast. They should all be optimized. Why is just that one optimized? I'm dying. So what are all these methods it tries to do respond to with? So this is the list here, and I do some more puts debugging because that's how I roll. And I see, well, okay, we're going along here, but then all of a sudden we have this one defined method under attribute. What the hell is that about? I don't understand this. And then I see it's doing it twice. Why is it doing it twice? Why? I don't know. Thanks, Active Model. I appreciate that. Why did you call these twice? I have no idea. So my doubts are like way up here. I don't know what. So I want to know, does anyone actually use this? Like, there's got to be somebody that does. And I just have to say, well, should you be using this? Like, if you are using this, are you sure you need to? Are you sure you need to? So I'm totally lost. Where were we? So this is our stack. We called post.new, respond to, it called active record, which called into active model, which called into active model, which called back into active record. If you're like me, you can only keep like 1 or 2 stack frames in your mind at the same time. So if you use Vim, learn these. Go look these up. It'll save your life. Right? So finally, we're back in active record, and we're doing some evals, and we want to know, well, what's the source of this method? We want to do a value lookup, typecast, and return that value back up. And if we look at the actual evaluated code, it looks like this. This seems fine. We look up the attribute. If it exists, return it. Done. This seems legit. So, but what about post.createdAt? Now, it looks a little more complicated now. We have this attributes cache, and we're doing this or equal thing, and then down here we have this like column thing, and why is it specific to SQLite column? Like, what's the deal with that? Like, my doubts are increasing. So we'll go look at attribute cast code. This is what actually determines the string that gets evaled, and we say, well, what is this typecast code thing here? Let's go look at that. Go look at that. And this is it's generating the string that gets evaled. So like, okay, well, this is the string that gets evaled, okay. But then we look up from this code, like 10 lines, and we see this. We're like, wait a minute. Those look exactly the same. Why? So my doubts are just off the charts here. I have no idea what's wrong. Like, why is it this way? I'm dying. Too many doubts. So how to fix this? We want less dynamic code, consistent method definitions, matching speed, and we need it to do attribute lookup, column lookup, value typecasting, and typecast value caching. So this is actually the source of the new read attribute method. It does all of these, and I'm totally out of time, so I'm not going to talk about it specifically, but it does all of those things, and it makes it so that our evals look like this. The definition of def name is read attribute name. Done. The definition of post.createdAt is read attribute createdAt. Done. That is what we want to see. As a bonus feature in Postgres, any of you using Postgres will be happy about this. This actually returns true. Yes. So, side benefit of this, we got to delete tons of code. It makes me super happy. I love deleting code. Oh, yes. Remember from the amazing lightning talk last night, delete your code. So I want to end with clean code as a feature. And I finally want to say that don't throw the baby out with the bathwater. Like, I've ragged a lot on Rails today in these slides. But the thing is, the reason I'm ragging on it so much is because I look at it on a day-to-day basis. I see those warts. I find these places. My job is to improve Rails. And if I'm trying to improve Rails, then obviously I'm looking for the worst parts of it to improve. And I just wanted to share my job with you today. So thank you. I don't think I have time for questions.
I think 5 minutes will not kill anyone. If you have questions, this was phenomenal talk.
Oh, thank you.
Questions, comments, hugs? Oh, there's one over there. You can hug the unicorn too while you're on the stage. So,
Okay. How do you find the most sucky parts of the code?
What's that?
How do you find the most sucky parts of the Rails code?
How do I find the most sucky parts of the Rails code? I just open Vim. No, I'm just kidding. It's typically from like bugs that are reported, or like anytime there's like feature requests or bugs that are reported, like oftentimes we'll get bugs with patches saying like, hey, we should probably fix, I have this bug, we should probably fix it. And I look at it and I'm like, yeah, that fixes your bug, but why is our code that way? So then I go fix it. Sometimes I'll use, it depends, like sometimes I'll use code metrics like flog or flay to go look at the source code, but honestly, the flog and flay in Rails isn't actually insanely bad. It's more design issues. Like this particular one that I showed here with active record, the relationship between active record and active model with regard to this particular like defining attribute stuff is it's just poor design, and it's difficult for code metric tools to, rat that out. So I know that wasn't a very awesome answer, but.
Okay, one more question over there. Yes. Bart.
Hi. Is it actually possible to run multiple requests in a single process, or handle multiple requests in a single process on MRI? And why don't people do it generally?
Yes, it's possible, and second answer, I don't know.
Great answer.
Yeah. So I guess I think part of the problem is that we don't have any good, until recently we haven't had any good threaded web servers. Most of them have been process forking, like Unicorn just forks processes. What was Evan's new one? Puma is I guess the first real threaded server. So I'm actually kind of surprised that more people don't run their Rails processes in a threaded server, because we can get I/O concurrency on MRI, and a lot of time that I spend in my apps is doing I/O concurrency, like with the database or web services or whatever. Yehuda, tell me.
I just want to follow up and say, if you have more than one process per core on your machine, you can benefit from using threads in Rails.
Even on MRI.
Yes. So on MRI, it's one process per core. On JRuby, it's one process. But if you have 4 processes per core, there is opportunity for parallelization.
Okay, thank you.
Thank you.
Thank you.